See, pretty cool. Okay, so yesterday we reiterated that you don't have to factor trinomials. So if you see a question with this, like in my notes, you don't have to factor those. It's just we used to before, and I had never updated it, so that's my bad. So we're just going to scratch those out, and we're going to put in what they actually would be. So this one would be n minus 3, n minus 2. And this one would be n minus 5, n minus 6.
So it's like the factor trinomial, this is like, it's definitely not going to be.
You can't. They can't do that to you.
I feel like it's not one of those things where it's like, oh, don't worry about it.
No, it cannot be on there. There is a time where you could use factoring to do something useful, which we'll talk about. But if you're not good at factoring trinomials, you could avoid it the whole time. And I'll show you guys that probably today. So you don't need to stress about diamond method. All right, doing these questions, rational expressions. The first thing you always had to do was factor. We've already done the factoring. But in the factoring stage, I do put brackets around any binomials that I have that I can't factor. So that n minus 2 and n plus 4, I put brackets around. I do think that's an important step, even though it's an unnecessary one, just because it reminds you that n minus 2 is a package, right? Like it has to stay together or be removed together. Right? It's stuck like that. The second step that you do is your non-permissible values. Those are things that cause you to divide by 0, right? If you had to explain what a non-permissible value is, it's values that make you divide by 0. So looking at this one, values that cause me to divide by 0 would be n cannot equal 3, 2, 5, or 6. Because this would be 0 if it was 3, this would be 0 if it was 2, that would be 0 if it was 5, that would be 0 if it was 6. So remember, you're looking in your denominator for your non-permissible values. My guess is that you do get at least one non-permissible value question on your diploma, probably even 2. Fantastic. The third step is simplify. Now, when we simplify, our goal is to write it as, make it into one fraction, then reduce it. That's what simplify means to us. However, sometimes, and not all the time, it's pretty rare actually, you could reduce it before you make it into 1. So for instance, if I look at this first fraction right here that I'm circling in green, could I reduce that before we even start combining those fractions? Is there something on the top that would cancel something on the bottom? Yeah, there's an n minus 2 and an n minus 2. And if you can reduce it before you turn it into one fraction, it actually makes your life significantly easier. So I would definitely do that if you see it. If you mess that up and you didn't see that on a test, that's fine. You wouldn't be wrong. You're just making the question a little bit longer than you need to. Once I reduce it like that, I'm going to rewrite it so that my question looks nice and neat. My first fraction now has nothing on the top, so we put a 1. The denominator now only has an n minus 3. It's still a subtraction question. The other one has an n plus 4 on the top. Notice that I'm still doing brackets around it. And the bottom has n minus 5, n minus 6. Cool, so we factored, we did our Npvs, and we actually reduced it a little bit before we did anything else. Now, adding and subtracting. To write it as one fraction when you're adding and subtracting, you have to have a common denominator. To get a common denominator, you look for entire packages that each fraction has. For instance, if I look at this first one, I notice that this one has an n minus 3 in the denominator as a package. I don't view that as an n and a minus 3. I view it as one thing, an n minus 3. And then I look at the second fraction and see if there's an n minus 3 in that second fraction. There isn't. So what I do is I multiply by n minus 3. I give it that package. And what I do to the bottom, I do to the top. I'm going to continue that process until I've looked at every single thing on the bottom of my fractions. The next thing I see on the bottom is an n minus 5. It's in the second fraction. If I look at the first fraction, it doesn't have an n minus 5, so I need to multiply by n minus 5. And what I do to the bottom, I do to the top. The next package that I see in the denominator is n minus 6. Since the second fraction has an n minus 6, the first fraction needs to have an n minus 6 as well. Beautiful. You have now created a common denominator. The denominator is n minus 6 times n minus 5 times n minus 3. And both fractions have it. The reason this is handy is because now we can combine this to be one fraction. Now, if you missed yesterday, or you didn't watch the video from yesterday, which most of you probably haven't yet, or if you're watching this thrilling YouTube series and you've skipped episode 205, then you wouldn't know what I'm talking about. Thanks for laughing at that. I appreciate it. When you have fractions, we're just going to do a little thing on the side. You don't need to write this down. If I had a fraction and I had 1 over 4, we'd say that's 1/4. And if I added, let's say 5 over 4, that'd be 5/4. In total, I would have 6/4, correct? Because I added the tops and the bottom stayed the same. The bottom's telling me what I have. That same kind of idea is going to work for us in this question. So now that I have a common denominator, I can write this as one fraction, where the bottom just stays the same. On the bottom, I'm going to have divide by n minus 6, n minus 5, n minus 3. But on the top, I'm still separated. So on the top, I have n minus 6 times n minus 5. That came from the first fraction. And I'm still subtracting. And then I have n plus 4, n minus 3 from the second fraction. Does everybody see that, like how I've combined that? It's a little weird, and then when it's a big question like this, it looks awkward. And it's like, whoa, where did those things come from? The bottoms, the common denominators, combine to be 1, but the tops are still separated. The reason they're separated is because I can't subtract those things right now. I have no idea how I would subtract 2 binomials multiplied by 2 binomials multiplied. That doesn't make sense. So what you need to do when you're adding and subtracting is you need to expand the top so that you can actually add and subtract the tops. So we're going to look at this green side, and we are going to expand that. Expand means multiply. When we multiply that together, we are going to get n squared minus 6n minus 5n plus 30. Then we're going to expand the red side. When we expand the red side, we're going to get n squared plus 4n minus 3n minus 12. And the denominator hasn't changed. The denominator, once you've set it, almost never changes. Just kind of stays through the whole question. All right, marking these types of questions and watching you guys do these over the past few years, the biggest number one mistake people make, they get all the way to that moment, and then they put this negative sign, and they put it right there, which isn't wrong. But the problem is when you expand, that negative represented a -1. And you never expanded that -1. Right? You never multiplied that coefficient in. So when you expand that red side, you actually still had to have brackets around it. And then you had to expand that negative into the brackets. That's what makes subtraction questions harder than adding questions. Adding questions, it doesn't matter, right? Because when you multiply a +1 in, everything stays the same. Subtraction questions are harder because you have to bring the negative in, and people forget to do that. It's also a predictable mistake. Predictable mistakes are like the worst ones because that means the right answer is probably on the test if it's multiple choice. So be very aware of subtraction questions that you have a negative that must go to everything in the right fraction. When I do that, I now have the green side didn't change at all, so I still have n squared minus 6n minus 5n plus 30. And the red side is now -n squared, -4n, +3n, +12. All the symbols in the red side changed. The denominator has stayed the same. n minus 6, n minus 5, n minus 3. Okay, just to recap what we've done, because this is definitely a hard question. We got ourselves a common denominator. Once we got that common denominator, we combined it to become one fraction. And then our goal was to actually combine the numerator as well. And we can't combine the numerator until we expand, because once we've expanded, we should be able to combine like terms. So all we've done the last two steps is expand. But now that we're at that stage, if you look at your numerator, you have all monomials. I shouldn't say monomials, but that's okay. But you have a whole bunch of terms, and you have a whole bunch of like terms. So for instance, the n squares could combine. N squared minus n squared would equal 0. So they actually cancel each other out. I have a whole bunch of n's. I have minus 6n, minus 5n, minus 4n, plus 3n. If you put that in your calculator, so -6 minus 5 minus 4 plus 3, you should end up with -12n. And then I have a couple constants. So my constants are plus 30 plus 12 to equal plus 42. And the denominator has not changed. I have now successfully taken those two fractions which were being subtracted, and I've combined them into one fraction, and it was a pain. Now, you know you're done simplifying when you can check two things off the list. First thing, you can't factor anymore. If I look at that, could I factor it? I could. What could I do? Yeah, if I look at the top, I could divide 12 and 42 by 6. So I could take a GCF of 6 out. In fact, I could take a GCF of -6 out if I wanted to reverse which order those numbers come in. I'm just going to do 6 for now because it's not going to make a difference. If I do that, that leaves me with -2n plus 7. And the denominator stays the same. So I know I'm done the question. When I can't factor, I look at that, I can't factor it. And I know I'm done the question when I can't cancel anymore. When you're canceling or simplifying or reducing, all the same thing, you can only cancel binomials with binomials, right? Packages with entire packages. So for instance, I do see that there's an n here and there's an n here, but they cannot cancel each other out because those n's are both attached to different packages. This n is a part of -2n plus 7. That can only cancel with other -2n plus 7s. And there isn't one of those. My monomial of 6 out front can only cancel with other monomials of 6s. There is no other monomial out front. So that means it can't reduce with anything. That means this is my final answer. And I am done. That's a hard one. You guys missed like the easy ones leading up to it. So if you're kind of like, whoa, definitely go watch yesterday's video to maybe get like the easier level of it. That would be, if they gave you that question, like that would be hard. That'd be one of the harder rational expression questions, I would think. Yeah. All right. Solving. So we're going to solve rational expressions. The difference between solving and simplifying is the presence of an equal sign. If you look back at all the questions that I've done in this unit, there's never once been an equal sign in the question. Right? Like look up here. There was no equal sign in this question. Look up here. No equal sign in this question. And you could keep going. We've never had one. Now, looking at these questions, there is an equal sign in the questions. The way that changes things. When you're simplifying, you should still be left with a fraction. And you should be left with some sort of expression. When you see an equal sign, that means your answer should be x equals a number. And then that number makes the entire equation from the beginning true. That's the difference. And it seems simple now when I talk about it, but then when you get to a test and you're simplifying, there's a lot of times where people all of a sudden put their own equal sign into the question. And it's like, whoa, there's no equal sign there. They make it equal 0 or they make it equal something, and then they start solving when reality is all they had to do was simplify. They didn't have to solve. Same can be said for solving. Some people get so good at simplifying, then an equal sign shows up and they don't know what to do. They get a common denominator and then they're done. And they're like, I don't know what I'm doing. Okay, to solve, you're going to follow 3 steps. First step, factor. You can't factor anything in this first question. So we're just going to move on. There's also no binomial, so I'm not going to put brackets on anything. Second step is state your Npvs. All right, these things never change. So what's your Npv for this question? Yeah. This Npv would be x cannot equal 0. If it equaled 0, these 2 monomials that have x's would then equal 0. And that's no good for us. Fantastic. Third step, you now need to simplify. In this case, solve. The way you solve is by getting a common denominator, but you have to do it for every fraction. This time there's 3 fractions. So to get a common denominator with monomials, I look at the numbers first. I have 2, 5, and 10. I want to find the lowest number they all can multiply to become. What's the lowest number they all multiply to become? 10. So to make the first one 10, we would multiply by 5, top and bottom. To make the second one,
2x.
we'd have to multiply by, yeah, you're right, 2x. I'm just going to do 2 for now. But you are right. I'm just trying to make it 10. To make the third one 10, we don't have to multiply by anything because it's already 10. Then I look at my x values in my monomials. If there was an x squared, then I'd need to make all of them x squared. If there was an x to the power of 9, I'd have to make all of them x to the power of 9. In this case, there's just an x, so I have to make sure they all have an x. The middle one doesn't, so I multiply by 2x instead of just 2. Okay, I'm going to rewrite my answer now. So looking at the first fraction, multiply the top and the bottom by 5, I end up with 5 divided by 10x. Look at the second fraction. Instead of having 2, I have 2 times 2x, which is 4x. Looking at the third one, I did nothing, so it's 1 over 10x. Everyone's good with my common denominator? All right. The most confusing thing that we do that people they'll mess it up when they go back to simplifying questions is if you have a common denominator and an equal sign, and that's important. I'm going to write this down. If you have a common denominator and, look how big I wrote the word and, it means it's really important, and an equal sign. Right. You look like an O. And an equal sign. You can cancel all denominators. You know there's words that you don't remember how they're spelled? Cancel is the one for me.
Pencil?
Cancel.
Oh.
I'm always, is it C-A-N-C-L-E or E-L?
Oh my god, wait, important question.
Right?
I spell like Tennessee.
Now that we know how to spell, oh, are you okay?
Yeah.
Now that you know how to spell cancel in Tennessee, the rule we were trying to get to is if you have a common denominator and an equal sign. So don't mess that up. Like when we're doing adding, subtracting, we do have a common denominator, but not an equal sign. If you have a common denominator and an equal sign, you can cancel out all the denominators, which is actually brilliant because then all you have for a question is 5 minus 4x equals 1. When they were marking your diploma, they had a question quite similar to this one, where it was 3 fractions. I think they were being added or subtracted. Maybe, I can't remember. I think they were being added or subtracted. And they would give you 1 out of 2 marks if you got to the stage of the common denominator and canceling it out. That's 1 out of 2 marks just for that. And it was a hard question. So it actually was a quadratic, which took some time and effort to solve. And you still got 50% if you just did that, which isn't that bad, right? So at that stage, once you've gotten rid of it, you now have an equation with no denominators. So you need to check to see if the exponents are linear or quadratic. Linear means the highest exponent is 1. Quadratic means the highest exponent is 2. If you have anything bigger than 2, you probably made a mistake. I would go back and check your work. You probably missed canceling something out or reducing something. In our case, we have a linear equation. Highest exponent is 1. The way we solve a linear equation is by getting x by itself. So we're going to move everything away from the x, starting with the 5, right? Because that's a plus 5. The opposite of plus 5 would be minus 5. So we subtract 5 from both sides. This gives me negative 4x equals 1. Then you need to get rid of the negative 4. To get rid of the negative 4, you would have to divide by negative 4. Giving me my final answer of x equals negative 1 over 4. And that is the solution to your rational expression.
Isn't
4x.
Yeah.
And then minus 4.
Okay, so you can solve these types of questions multiple ways. So for instance, like that's how I would do it. But you could do this in other methods. And I'm going to write them down on the side right now.
How is 1 minus 5 just still 1?
Oh my goodness. Why did you guys let me do that? I was too excited talking about our facts. You're right. Okay, 1 minus 5 is definitely -4. -4 divided by -4 is definitely 1.
Oh, I got the same thing. I just erased all of them.
No, that was my bad. I solved that wrong, and you guys just went right down that rabbit hole with me and allowed me.
Clearly the one just now that got confused.
Okay, and you could, like you said, you could solve that a different way. So to solve that a different way, like to solve it the way that Will said, you could move the x's to the other side. So you could add 4x. And that would give you 5 equals 1 plus 4x. Then you could move the 1 over, subtract 1 from both sides, to say 4 equals 4x. Oh, my computer's lagging. That's why it's doing that. And then you could divide by 4. But you always will get the same answer of x equals 1. Different method, same answer. Here's the beauty of rational expressions. You can check your answer. So remember that you're finding a value for the letter or the variable that makes the original equation true. So if you look at this original equation, the original equation was 1 over 2x minus 2 over 5 equals 1 over 10x. We said x equals 1. If that's true, that means 1 over 2 times 1 minus 2 over 5 equals 1 over 10 times 1. That's 1 over 2 minus 2 over 5 equals 1 over 10. If you put that in your calculator and you calculate both sides, you will get 0.1 equals 0.1.
Yes.
That's called verifying your solution. Right? You take your answer, you put it back into the original equation, you calculate both sides, and you prove that it's equal to each other. That's kind of the beauty of rational expressions. You should know if you're right or wrong. In fact, like people on tests will do the question and then they'll write, I know this is wrong. Like, I have verified this is wrong. I don't know what I did wrong, but I know this is not the right answer. Like, have mercy on me, please. Yeah, I feel that too. When I see that, I'm like, I get that. I get that person. I tried really hard, please. Awesome. We'll do a little bit of a harder one. So the first one was kind of easier because it was all monomials. If you look at this second question, as I slowly try to erase my verification. Oh my goodness, this is a process and a half. Should have done so much work. Now that I've erased all that. We'll do the second question. It's a little trickier. So when you get a rational expression, so when you get to the unit on the diploma where you see fractions like this, remember there's 3 steps. Factor, NPV, then solve or simplify. Start with factoring. If you skip the factoring step, you are making your life way too difficult, probably impossible. So you need to make sure you follow those steps and be meticulous at it, right? Don't go quick. So if I look at 3x plus 1, I'm going to put brackets around it. I'm going to look at that and think to myself, could I take a greatest common factor out? I can't. Nothing divides into 3 and 1. I then ask myself, could I square root all of that? No, I can't square root 3. Then I move on to the next thing. In the denominator, I have x squared minus 1. Can I take a greatest common factor out of that? No, there's no letter or number that divides out of both. Could I square root that, though? Can I square root x squared? Yes. Certainly. Can I square root 1? Certainly. Do I have a difference question, meaning subtraction? Absolutely. So that's a difference of squares. When you factor a difference of squares, remember you're square rooting everything to get x minus 1. And then you get the same thing but with a plus sign. If you don't factor this problem, it is very hard. You look at your second fraction. Look at the top. I have negative x. There's nothing I can factor out of a monomial negative x. I look at the denominator. I have x plus 1. There's nothing that I can factor out of x plus 1. No GCF. I can't square root it. Plus, it's an addition question, so it just stays as x plus 1. That is always your first step. Your second step, and it does have to be in this order, is you have to find your non-permissible values now. Your non-permissible values would be x cannot equal positive or negative 1. And that's the way I would write it, with a plus minus symbol. If you wrote it x cannot equal 1 or negative 1, it's the same thing. Beautiful. Now you can start simplifying. In this case, solving. To solve, you need to get a common denominator as your first step. When I'm getting a common denominator, I look at packages. The first fraction has an x minus 1. The second fraction does not. So I give it an x minus 1. The first fraction has an x plus 1. The second fraction has an x plus 1. So I don't need to do anything with it. I now have a common denominator and an equal sign. Therefore, I can cancel out my denominators, and I am left with 3x plus 1 equals negative x times x minus 1. Beautiful. To solve this thing, if there's any expansion that needs to happen, you need to do it first. There is expansion here. I need to multiply this negative x into the brackets. That gives me 3x plus 1 equals negative x squared plus x. Right? Negative x times x is negative x squared. Negative x times negative 1 is positive x. Okay. You got a common denominator, you crossed out the denominator, you expanded, and now you check the type of equation you have. If you look, do you have a quadratic or a linear? Quadratic, right? The highest exponent is 2. To solve a quadratic is different than solving a linear. You're not going to be able to get x by itself because you have x squared terms and x terms, and they'll never go together. So you'll never be able to get the x by itself. So what we do is we set up something called general form. That's where you're equal to 0. We move everything to one side. I'm going to move everything to the left. The reason I'm going to move everything to the left is I prefer my x squared to be positive, not negative. So I'm going to add x squared to the left. And then I'm going to subtract x. So that it cancels out on the right side. I don't know what I'm doing. Cancels out on the right side. And I now have an equation of x squared plus 2x plus 1 equals 0. That's called general form. There is 2 ways to solve quadratics. Way number 1 is factoring them. If you're comfortable with factoring them, I suggest that you do. So looking at that thing, if I was to factor it, I would use diamond method. Numbers that multiply to be 1 and add to be 2 would be 1 and 1. So this is x plus 1 times x plus 1 equals 0. You then look at each binomial in your factoring and you say what makes that binomial equal 0. So for instance, this first binomial would equal 0 if x equaled -1. The second binomial would also be x equals -1. That means your answer to this question is that x equals -1. That's the method you could use by factoring. If you try to factor and you can't, and you're like, I don't remember how to do diamond method, and you're stuck, and that can be a frustrating moment, remember that you can solve quadratics by using the quadratic formula. That will work for every single question, even the ones that don't factor. So use the quad formula. This is why you don't have to know how to factor quadratics. This is the only time they would ever ask you to factor it. But there's a good chance that you could just use the quad formula for every single question. The quad formula is on your formula sheet. So if you look at the bottom, I think bottom right-hand corner of your formula sheet, it's -b plus or minus b squared minus 4ac divided by 2a. Bottom left-hand corner. So the bottom left-hand corner of your formula sheet is the quadratic formula.
We get a quad formula or formula sheet during the diploma.
Yep.
Yes.
Yeah, you'll have that formula sheet for your diploma exam.
Like already sitting there?
It'll be in the booklet. So you know when you guys did your diploma yesterday, which you didn't get to do yesterday, but you know how they're like you open up the booklet and there's things that could rip out? There will be a formula sheet right in your booklet that you'll be able to rip out and use the whole test. And a ton of extra paper.
And there's like written response too.
Yep.
And
Yep.
is there numeric response?
Yep. Just every test I've given you this year looks the exact same as a diploma.
Okay.
Like the formatting, everything is the same.
I'm nervous. How many questions are there?
40 marks, I think.
40.
Marks. So one written response could be 2 marks or
Okay, that's actually not that bad.
Not
For
that
some
bad.
reason I thought it was like 100.
Nope.
Wasn't it like 100 in grade 10?
Remember grade 10?
Social studies does that. Social studies has really big tests, especially grade 10, they do like 100 or something. Okay, how to use the quad formula. If you look at your quadratic, and I'm just going to write this down here again so it's kind of on its own. The number in front of the x squared is a. The number in front of the x is b. The number by itself is c. If there is no number in a spot, like for instance, there's no number in front of the x squared, the number is 1. The only number that could be 0, if you're doing quad formula, is b or c. So if there was no x's or there was no c value, you would say it's 0.
Oh, full house.
Full house.
That's Chris.
Don't know. So if we do the quad formula, that would be x equals -2 plus or minus the square root of 2 squared minus 4 times 1 times 1, all divided by 2 times 1. My suggestion when you do the quad formula is to calculate what's underneath the root sign first. So 2 squared minus 4 times 1 is 0. And calculate what's on the bottom. 2 times 1 is 2. That's my suggestion. Just saves you from maybe making a calculator mistake. And then you should always get 2 answers. They might be the same, but you should always get 2 answers. So for instance, if I do -2 plus the square root of 0 divided by 2, and I do -2 minus the square root of 0 plus 2 divided by 2, you should always get 2 answers. One is when you add the square root. 1 is when you subtract the square root.
The way you're supposed to do it is like, well, once you have everything in the square root, it's you go -2 plus to the square root, and then you divide by 2.
Yes, yes.
Cool.
You calculate everything on the top, right? Like you just said, -2 plus the square root of 0, and then divided by 2. And if you're doing that in your calculator, I would definitely do it in chunks like that. Otherwise, sometimes your calculator will divide things differently. Or maybe you just made a little mistake in your calculator, and that just saves you from making those little mistakes. But you'll notice both questions got an answer of x equals -1. Fantastic. We talked about this during the year on rational expressions. When you get an answer, you need to check it with your Npvs. So if you look, we said our answer was x equals -1. If you look at your Npvs back at the start of the question, we found that x cannot equal -1. Therefore, these answers are extraneous roots. That's the terminology. Extraneous solution, extraneous root. You must write it still, so you put the -1, and then all you have to do is cross it out. But you still have to write it and cross it out. That's you demonstrating, hey, I know algebraically this is an answer, but I also know it's not a proper answer. So you have to like show you found it and then show that you denied it being a good enough answer. For a question like this, where now there is no answer, the solution would be no solution. And you would have to write no solution. Assume that the person marking your diploma has no idea about anything with math. So they were looking for an answer. If you didn't put an answer and you didn't put no solution, they assume that you don't know anything. They don't assume that you know there's no solution. Right? So state that there's no solution. Demonstrate you know it. Okay, we'll do one more. Then we'll be done. This is a rational expression. The first thing you want to do with any rational expression is factor. Okay, when I factor, this becomes x over x minus 3. I'm so sorry that it's getting squiggly like that. It's when my computer starts to lag. Equals -6 divided by, I will do that factoring quick. You wouldn't have to do it. So if you're not good at diamond method, that's okay. But just for review, you're looking for things that multiply to be 15, add to be -8, -3, -5. That means this is x minus 3, x minus 5. Awesome. First step, factor. We did that. What's the second step? Npvs, things you can't have as your answer. What I can't have as my answer is +3 or +5. Both of those numbers would cause me to divide by 0. Beautiful. Now you're on the third step. Third step is solve. The way we're going to solve this is by getting a common denominator. To get a common denominator, we are going to look at our packages, our sets of brackets. The first fraction has an x minus 3. That means the second fraction has to have an x minus 3, which it already does. Wonderful. The second fraction has an x minus 5. The first fraction does not. So we need to give it an x minus 5. And we multiply that by the top and by the bottom, like that. Because we have an equal sign and a common denominator, you can cross out your denominators. But you must have an equal sign. Please, please, please don't do that for adding and subtracting questions. Only works for solving questions. This gives me x bracket x minus 5 equals -6. To solve, you must expand first. So for a question like this, that x has to come in the brackets to become x squared minus 5x equals negative 6. Now that I got a common denominator, cancel out my common denominator, and expanded, I can check the type of question I have. This is a quadratic question because the highest exponent is 2. That means I must be equal to 0. Right now I'm equal to negative 6. So I need to move that negative 6 over by adding 6, which gives me x squared minus 5x plus 6 equals 0. If you are confident with your factoring, factor it. If you are not, then use the quadratic formula. For the quadratic formula, a would equal 1, b would equal negative 5, c would equal 6. The quad formula is negative b plus or minus b squared minus 4ac divided by 2a. I'm going to do the quadratic formula so you can see the answers. When I substitute things, I use brackets. So this becomes negative bracket negative 5 plus or minus the root sign of bracket negative 5 squared. Those brackets are important. Times 4 times bracket 1 times bracket 6. All divided by 2 times 1. I then do some simplifying before I just throw that in my calculator. The first thing that I'm going to focus in on is the negative b. So negative negative 5. If I put that in my calculator, that equals positive 5. I then have plus or minus the square root of. And I put this in my calculator. Negative 5 squared minus 4 times 1 times 6. You have to put brackets around your negative 5 when you square it. Remember in your calculator, if you don't put brackets, it will give you an answer of negative 25. And we know that negative 5 times negative 5 is actually positive 25. So make sure you put brackets around things. I've been stressing that all year for a reason. If you put this in your calculator, you should end up with 1. And in the denominator, 2 times 1 is 2. That's how I do it. So I now have x equals 5 plus root 1 divided by 2. I also have x equals 5 x equals 5 minus root 1 over 2. You need to do both.
Even if it's like a negative, you still have to show that like it doesn't.
Yeah. You still have to go as far as you can. So if it was a negative under the root sign, at that point, you could cross it out and say no solution. But if you had that, then you need to do both, even if one of them doesn't work. So if we put these in our calculators, the first one, 5 plus root 1 divided by 2 equals 3. The second one, 5 minus 1 divided by 2 is 2. And if you look, one of those answers doesn't work because of your NPV. We said x cannot equal 3. Last year when we did the diploma exam, because the teachers get to do it too, or we get to look at it, we had a question kind of similar to this, where you had to solve it, and you got 2 answers, and one of the answers was not acceptable because of NPVs. Myself, I see answers pretty quick. I've done a lot of math. So I didn't even write x equals 3 because I knew it couldn't equal 3. All I put was x equals 2. And technically, I lost half a mark for that. You have to write x equals 3, and then you have to deny it as a solution. And then put a box under the answer you want. And it has to be done that way. You don't have a choice. Okay? So accept one answer deny the other. And don't just do it in your head. Write it, show it.
Isn't that what we do?
Yeah, same unit. Beautiful. We will do word problems tomorrow and hopefully some polynomial stuff.